This video will teach you about types of decimals and converting positive and negative fractions to decimals. So in previous grades, you've learned how to convert fractions to decimals, so we're just going to also use our knowledge of positive and negative values. As you're going through the video, you should copy down all of the notes on your note sheet, and this includes definitions, examples, and the we-dos. So our first definition is terminating decimal. Again, this should be copied down in your notes. Terminating decimal is a decimal that ends, it does not repeat. So we have our examples down at the bottom, negative 50 hundredths, 375 thousandths, and negative 75 hundredths. So these decimals, they end, they do not repeat over and over again. So again, definitions and examples should be copied down on your note sheet. Our next definition is repeating decimal. Some of us have learned repeating decimals or call them as recurring decimals, or you can also call them non-terminating decimals, meaning that they don't end. They just go over, or they just continue with the same numbers again and again. So a repeating decimal is a decimal with numbers that occur again and again or in a pattern. So our examples are down below. If you look here, we have negative 555 thousandths, and since the 5 is repeating, then I can put the repeating bar over the first 5. So we can say it also as negative 5/10ths repeating. Our next example, we have 4,747 10,000ths. But since the 4 and the 7 keep repeating, we can put the repeating bar over, the repeating bar over the 4 and the 7, the first 4 and the 7. And we can say it as 47 hundredths repeating. And our last example is negative 33 hundredths, and since the 3 is going to repeat, we can put the repeating bar over the first 3 and say it as negative 3/10ths repeating. So again, this definition and the example should be copied down in your notes. So this is we-do number 1, an example of terminating decimals. Remember, a terminating decimal is a decimal that ends. So let's convert negative 1/8 to a decimal. And first, remember that the fraction bar means that we should divide. So if we set it up, I'll set it up underneath. The numerator is always going to go in the inside. And again, don't worry about that negative symbol just yet, because we'll put that on at the end once we're done dividing. So the numerator goes inside, denominator goes outside, and then we just divide. Since 8 can't go into 1, I add my decimal point. I add my decimal point, and then I'll go ahead and bring it up. After I add my decimal point, I can add a 0. So now 8 can go into 10 one whole time. So I know that 1 times 8 is 8, and then I subtract. Now I look at this 1.0 as 10. 10 minus 8 I know is 2, and then I can add another 0 and then bring it down, because 8 can't go into 2, but 8 can go into 20 2 whole times, and I know that 2 times 8 is 16. I go ahead and subtract, I bring down, and that equals 4. 8 can't go into 4, so I add another 0 and then bring that down. So now I know that 8 can go into 40 5 whole times. 5 times 8 is 40, and I subtract, and I have a remainder of 0. So here this decimal ends, and since, remember, it was negative to begin with, so our answer as a decimal is going to be negative. So our final answer, negative 1/8 as a decimal, is negative 125 thousandths. So again, we just divide. This is we-do number 2, repeating decimals, or remember, some people call them recurring decimals or non-terminating decimals. So this problem is convert 7/11ths to a decimal. So again, remember that the fraction bar means to divide, so we can apply long division. So I'll set up my work down at the bottom. The numerator goes inside, denominator goes outside. And then I can go ahead and divide. Since 11 cannot go into 7, I'll add my decimal point, and then I'll go ahead and bring it up. What is happening? And I'll go ahead and bring it up, and then I can add my 0. 11 can go into, now you can think of this as 70. 11 can go into 76 whole times, and I know that 6 times 11 is 66, and then I subtract 70 minus 66, I know is 4. 11 can't go into 4, so I add another 0, and then I go ahead and bring that down. Now I can do, 11 can go into 43 whole times. 3 times 11 I know is 33. And then I go ahead and subtract. 40 minus 33 I know is 7. Since 11 can't go into 7, I add another 0, and I bring that down. You should start noticing something. So 11 can go into 70 again 6 whole times. So start looking at what's happening with our quotient up here. 6 times 11 I know is 66, and then I'll subtract, and that's 4. I'll extend this. 11 can't go into 4, so I add my 0, and then I can bring it down. 11 can go into 43 whole times. 3 times 11 I know is 33. Then I'll subtract, this is 7. So what's happening is that our math, it's repeating, and then if I look at our quotient, that's also repeating. So I can end here, and then if I notice, the 6 and the 3 keep repeating. So since the 6 and the 3 keep repeating, the repeating bar goes over the 6 and the 3. So we can say that 7/11ths as a decimal would be 63/100ths repeating, because the 6 and the 3 keep repeating over and over again if we were to continue dividing. So again, 7/11ths as a decimal is 63/100ths repeating. So after you're done the notes, you need to, 1, complete the 4 practice problems on the back of your sheet. So on the 4 practice problems, you're given 4 fractions. You need to show your work in the middle column and then write your final answer in the decimal column. So convert the fractions to decimals, and remember to show your work. If you have questions, refer to your notes or go back to the video.